Hey folks, I put together a little screencast here, working out some of the problems that was on the quiz that you did in class. I'm not going to work through every single one, just the ones that may have caused you some difficulty. So, the first one I thought we'd look at is 1B. You were asked to determine, in one, you were asked to determine whether each equation defines y as a function of x. Most of you did a really good job on part A, that you recognized y was a function of x. And while most of you did a pretty good job here on B, I thought we'd go ahead and look at it as well. Keep in mind when you're doing a solution for a problem like this, the key thing is, can you solve the equation for y? Can you get y by itself? Can you get y to equal a single expression involving x? So I start this problem off by solving for y by simply adding x squared to both sides. And that gives me y squared equals x squared plus 9. And then we're going to take the square root of both sides. Keep in mind when you take the square root, you have to insert the plus or minus. Because we have the plus or minus there, we really have two separate equations here. Y equals the square root of x squared plus 9, or y equals negative square root x squared plus 9. So since y is not equal to a single expression involving x, the equation in 1b does not define y as a function of x. Okay, the next one in number 2, you had I think 4 functions given in 2, where you were asked to determine the domain for the functions. And as I will always do, I'll ask you to write your answer in interval notation. So in A, I think everyone did a really good job. They got A. They recognized it was all reals. So I thought we'd start off by working through B. Here your function is g of x equals x plus 1 over x squared minus x minus 6. So when we start to think of finding the domain, keep in mind when you're finding the domain, you want to find values that you can put in for the variable so that nothing bad happens. Well, here, since we have variables in the denominator is x squared minus x minus 6, we would have to worry about a number going in for x that would cause the denominator to be 0. So any number, any value for x that makes the denominator 0, it can't be in the domain. So that kind of gives me a place to start. Let's try to find those values of x that makes the denominator 0. So let's try to find those values of x where x squared minus x minus 6 is equal to 0. And that factors, and then you can set each factor equal to 0, and you get x is 3 or x is negative 2. Those are two values of x that will make the denominator 0. They cannot be in the domain. So our domain is any other real number you can think of except for 3 and negative 2. So in interval notation, your domain would look like this. Negative infinity to negative 2, parentheses, union with negative 2 to 3, parentheses around both there. Then finally, union with 3 to infinity. So the next one, I thought we'd look at 2c. Determine the domain of the function f of x equals square root 3x minus 4. Again, domain, we're trying to find values for x so that nothing bad happens. Well, here we have an even-indexed radical, square root. So since the function does have an even-indexed radical, we have to worry about negatives appearing under that radical. We have to worry about a value of x that would go in and produce a negative number to appear under the radical. So any values of x that would make what you see under the radical negative, we would have to exclude from the domain. So just remember this. What's under the radical, it cannot be negative. It could be positive or it could be 0. So what is under the radical must be positive or 0 that means we can set up the following inequality to find our domain. 3x minus 4 greater than or equal to 0. That's a pretty straightforward inequality to solve. You add 4 to both sides. It gives you 3x greater than or equal to 4. Divide by 4. And there's your domain. X is greater than or equal to 4/3. Any number that is larger than or equal to 4/3 could be put into the function for x, and you would not have a negative number up here under that radical. So in interval notation, x is greater than or equal to 4/3 would be a square bracket 4/3 comma infinity, and a parenthesis around the infinity. I'm not going to work through part D, but if you recall in part D, that square root 3x minus 4 was in the denominator of a fraction. So because it does appear in the denominator of a fraction, you now have the other thing to worry about, the other bad thing in function land to worry about, and that's 0 appearing in the denominator. So I could use my work from part C to tell me that the domain for part D is almost identical to what we have here in C, except now you cannot include the 4/3 because 4/3 is going to make what's under the radical. It's going to make that 0, and in part D, since this expression here was in the denominator, we can't divide by 0. So that's the domain for part D. Part D domain, and this is part C domain. The next one, I thought we'd check out number 4, the difference quotient one. Seemed to cause quite a few of you, some fits. So you're given the function x squared minus x plus 5. I asked you to determine the difference quotient and simplify it. The first thing I would do is write down what the difference quotient is. So there it is, f of x plus h minus f of x, all of that over h. Folks, remember, to evaluate f of x plus h, you will be putting x plus h, you will be putting it into the function for every occurrence of x. So f of x plus h is x plus h squared minus x plus h plus 5. That's x plus h going in for every occurrence of x. Then minus f of x. So there's f of x. So minus f of x. And then again, all of that's over h. Well, now it's a Nike problem. Just do it. Take your x plus h and square it. That's an x squared plus 2xh plus h squared. Distribute this negative 1, so minus x minus h plus 5. Distribute this negative 1 on through, and it gives you minus x squared plus x minus 5 all over h. And it looks like we'll have some stuff cancel out. It looks like the x squareds will cancel out, and the x's will cancel out, and the 5's will cancel out. So we actually have a lot to cancel out. That all that's left in the numerator is 2xh plus h squared minus h. And then, well, you could factor an h out of the numerator, and then you could cancel out those h's, which leaves you with 2x plus h minus 1. So that's the difference quotient, and it's simplified. The next one I thought we'd look at is number 8. Got a lot of strange answers here for number 8. I gave you this graph. I didn't tell you what the function is. It's irrelevant what the function is. Told you the viewing window was negative 10 to 10 by negative 2 to 2. No one asked this, but let me go ahead and mention it. If I give you a viewing window like this, I'm telling you the x-axis goes from negative 10 to 10. So there's negative 10 to 10. And the y-axis goes from negative 2 to 2. Negative 2 up to 2. And the question was, does this graph represent an even function, an odd function, or neither? And then explain. Well, the first thing that jumps out at me is that the graph that I'm seeing here it appears that it is symmetric about the y-axis, that over here, it's a mirror image of what I see over here. If I were to print this out on paper and I were to fold it right along the y-axis, I would see what's over here would match up perfectly with what I see over here. So since I see the graph is symmetric about the y-axis, and we know that even functions are symmetric about the y-axis, this graph represents an even function. And then the last one I thought we'd look at was number 9. Here I gave you an inequality, x squared minus 4 greater than or equal to 0, and I asked you to solve it by using the graph, and I supplied you with this graph. And again, write your answer in interval notation. This is the graph of x squared minus 4, and it's in the viewing window -5 to 5 on the x-axis by -5 to 5 on the y-axis. And we're trying to make some connections here. So first off, the function is x squared minus 4. The function x squared minus 4, it is equal to 0 where the graph intersects the x-axis. At these two values of x, that's where the function would be equal to 0. So where the graph crosses the x-axis at 2 and -2, that's where your function is equal to 0. Where the graph is above the x-axis, for those values of x that the graph is above the x-axis, well, if you're above the x-axis, your y-coordinates would be positive. Your functional values would be positive. That's where the inequality is greater than 0. Where the graph is below the x-axis, for those values of x that the graph is below the x-axis, that's where the function is negative. These y values are negative. But since I asked you to solve x squared minus 4 greater than or equal to 0, I make a note that where the graph is above the x-axis, that's where the function is greater than 0. So where is the function x squared minus 4 greater than or equal to 0? Well, we know it's equal to 0 at -2 and 2, and it's greater than 0 from 2 to infinity, and from -infinity to 2. So our answer in interval notation is parenthesis -infinity to -2, square bracket, union with square bracket 2 to infinity. So that's a quick rundown on some of the problems that you saw in your quiz. I hope that you got these correct, but if not, hopefully this helped you see where your mistake was. Thanks for watching. Goodbye.